Now we are going to solve the question number 26. In question number 26, it is asked, construct the transformation matrix that connects SZ diagonal basis to the SX diagonal basis so that your result is consistent with the general relation U equal to summation of R, BR, AR. So let us first write a operator that will operate on plus Z of a Z operator will give the plus is X. That means this operator will change the basis from plus SZ to the plus SX. Similarly, U operate on minus SZ will give minus SX. As we know that we can represent plus SX as 1 by root 2 plus SZ plus of minus SZ, and we know that sigma Z operate on plus SZ give minus SZ. That means we can write here it is 1 by root 2 sigma Z operate on plus SZ remains plus SZ. That means plus SZ, and this is sigma Z operate on sigma X operate on this, sigma Z operate on plus SZ will give minus plus SZ, and plus sigma X plus SZ. That means we can write 1 by root 2 sigma Z plus sigma X operate on plus SZ will give SX. That means our unitary operator here U is sigma Z plus sigma S. Now let us by root 2. Now let us check whether it gives whether it follows this relation. So let us operate sigma Z plus sigma X by root 2 on the state minus SZ, and we know that sigma Z in minus SZ will give minus SZ 1 by root 2, and sigma X minus SZ will give plus SZ. Here we have used sigma Z minus SZ will give minus sigma SZ, and sigma X minus SZ will give plus SZ. So it is nothing but 1 by root 2. 1 by root 2 will be there. So this is nothing but minus SX. So here our operator U is sigma Z plus sigma X by root 2. Now as we know from the question 8, the sigma Z and sigma X can be represented in terms of SZ and SZ operator. So let us in the basis of SZ, so let us check it. SZ means from the question 8 we know that SZ means SZ, we know that SZ means SZ means SZ will be H cut plus here plus is the eigencase corresponding to plus H cut by 2 of SZ operator minus and Sx is h cut minus plus 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 minus. So that means sigma z actually plus plus minus of minus minus, and sigma s actually minus plus and plus minus. So let us check that this u in its general relation, that means should be u should be here u should be here plus sx plus sz plus plus sorry minus sy minus minus sx minus sx minus sz. If operate on sz, this term will be 0 because of orthogonality of sz, and this term will be survive, so plus sx. And again if we operate on u operate on minus sz, this term will survive, it will give 1 orthogonality, and this term will 0 minus sy. So and if we represent it sx and minus sx in plus and in eigenkets of sz will get 1 by root 2 sx will be plus minus into plus minus minus by root 2 minus. So that means it will be 1 by root 2 plus minus plus this will be minus, so plus minus and minus of minus minus. So that means 1 by root 2, this and this term will give plus minus minus minus, that will nothing but is z sigma z, and this minus plus minus is actually a 6, that means 1 by root 2 sigma z plus sigma x. That means this general relation also holds. From the general relation we also get the same form of the matrix operator u. So we have solved the question number 26. Now we will solve the question 27. Here it is asked, suppose that fa is a function of a Hermitian operator A with the property a prime is equal to a prime a, that means a prime k's are the eigenkets of the Hermitian operator A. Now evaluate the matrix element B double prime fa B prime when the transformation matrix from the basis A prime to the B prime is known. That means the transformation matrix from A prime to B prime known. That means we know this matrix summation of I B I A I, because if we operate u a j, it will give pj. So we know this form, that means we know the form of U, that means we know the operator element uij, which is actually a I u a j, which is a I summation of k p k a k a j, that is actually summation of k a I p k a k a j. From orthonormality relation we know that this is actually, sorry, here there is a class of notations, so let me rightly notate it. These will be pi, I, this I will be on the upper side, that means ai, aj, ai, aj, ai, aj. This means, so from the orthonormality relation of these eigenkets we can write that summation of k ai b k is delta k j, that is actually nothing, summation of summation will be no there, that is equal to a I p j. We know all these elements. Now let us check, and another thing is a a suppose ai will be ai, so that means the function fa operate on any function ai will give f of ai ai. So now let us express these, that means let us express p double prime f of a p prime. Now I personally don't like this prime symbol, so let us actually represent it like that, pi fa p j. So we will calculate this term, so that will be, and here we will use the completeness relation of this ai. So that is actually, this means this is equal to summation of L m p I a l f of a am p j. So summation over L comma m p I a l, this is nothing but f of a m, because fa operator on am will give f am al am bj, and this from the orthonormality condition we know that this is actually delta lm, so lm pi al is f am delta lm am bj. So this will actually lm, one sum will be cancelled because of delta function, pl, it will be pl I al f of al al p j. So again this al will be in the upper part, that means This means AL PI is star if AL and AL PJ. Since we know every element, so we know these this element in the D basis. Now let us see the question number B of 27. Here it is asked, using the continuum analog of the result obtained A, evaluate P double prime F R P prime. So let us check it. It is an interesting problem. So let us check it. So F R, where R is the vector, where x square plus y square plus z square is magnitude, and x comma y comma z are the operators, right? So we have to calculate P double prime vector F R P prime vector. So from the completeness relation of the position case, let us write it here, that is minus infinity to plus infinity P T x double prime P double prime x double prime x double prime F R, another will be minus infinity to plus infinity T x prime x prime x prime P prime, that means minus infinity to plus infinity Tx prime Tx double prime P double prime x prime. Here this is actually x prime means vector, x prime means vector. Here the x prime actually contains xyz. Actually let us write it like R. This is R. So and this also. So let it dr double prime vector t r prime r prime r prime, everyone is vector. Here r double prime. So p r double prime r prime r double prime f r r prime, and this will be r prime p prime. So fr operate on r prime will give minus infinity to plus infinity dr prime dr double prime. This actually x r, actually this r double prime p double prime is star, and this is actually f r prime r double prime r prime p prime. So from the orthonormality we know that this is a delta function that will minus infinity to plus infinity dr prime dr double prime r double prime p double prime with star. It's complex conjugate. Star means complex conjugate. As we this will be delta r double prime minus r prime. This will be r prime p prime, which is actually minus infinity to plus infinity t r prime p double prime is star if r prime p prime. So let us say change the variable r prime to r, minus infinity to plus infinity dr. This will be r p double prime with star, and if r r p, this will be matrix. Now let us see what it is. We know this xp is actually xp is 1 by 2 pi h cut. It is 1 by root over 2 pi h cut e to the power I prime I p x, here px is. Now this r vector actually, this arcades actually can be also represented by x comma y comma z, where x is the x value of the position, y value of the position, z value of the position, and these k's can be written as x, y k's and z k's. Similarly, the p can also be written as px, py and pz. That means these are p actually x, px, y, py, z, pz. So that means it will be 1 by 2 pi h cut to the power 3 by 2 e to the power I pxx plus pyy plus pzz. That means 1 by 2 pi h cut to the power 3 by 2 e to the power I p dot r. Now, and dr actually dx, dy, dz. Not let it write in this fashion also. So that will become minus infinity to plus infinity dr. This will be e to the power minus I p double prime dot r if r e to the power I p prime r, that actually minus infinity to plus infinity dr e to the power I p prime minus p double prime dot r if r. Now this is a general form. Now let us assume one thing, that this if r is only function of the if modulus of r. It doesn't depend on the angle, or that means in radial coordinate it does not depend on the theta and phi. Then this can be reduced to as, and this p dot p dash, its modulus will be q. So here we can write dr means 0 to infinity r square dr 0 to pi sine theta d theta and d phi 0 to 2 pi. This will be to the power I q r cos theta, and this will be only function of r. That means 0 to infinity dr r square outside 2 pi h cut to the power 3 by 2 is there. 1 by 2 pi h cut to the power 3 by 2. So these actually minus 1 to plus 1 d cos theta. So we can change the variable. We do nothing. Y q r cos theta if r, and d phi will give 2 pi, so that means 2 pi by 2 pi h cut to the power 3 by 2, 0 to infinity dr r square fr. What it will give? It will give 1 by I q r e to the power I cos theta will give e to the power I q r cos theta, and the value of cos theta is -1 to +1, -1 to +1. That means what will get 2 pi by 2 pi h cut to the power 3 by 2, 0 to infinity dr r square fr by a function of r I q r. This will be to the power I q r minus e to the power minus I q r. So that is, there will be 4 pi because I take 1 2 here. This will be 2 pi h cut to the power 3 by 2 minus 0 to infinity dr r square fr. 1 r will be cancelled, so there will be no fr. So let us erase this. Fr, this will be sine qr pi q. So that means we have solved the question number 27, both A and B part. Now we will solve the question number 28. In question number 28, it is asked, let x and px be the coordinate and the linear momentum in one dimension. Evaluate the classical Poisson bracket x comma fpx. So let us first check this first question. A x f px classical. So it is del x into del f px minus del x del px into del f px del x. This is 0, that means it is del f px f px. Now in question B, it is asked, let x and px be the corresponding quantum mechanical operator. This time evaluate the commutator x comma exponential I px a by h cut. So we have to evaluate x comma e to the power I px a by h cut. So that means we have to evaluate, and we know that e to the power I px a by h cut is equal to summation of n equal to 0 to infinity I a by h cut to the power n 1 by n factorial px to the power n. So that means it will be x summation of n equal to 0 to infinity I a h cut to the power n 1 by n factorial px to the power n. That means we have to evaluate n equal to 0 to infinity I a by h cut to the power n by 1 by n factorial x comma px to the power n. That is equal to n equal to 0 to infinity I a by h cut to the power n 1 by n factorial x pxn minus pxn x. So let us first see this term. X px to the power n minus pxn x can be written as x px n minus 1 minus px x. We add this term, subtract extra term x pn minus 1, then we have to add this term again px x px n minus 1. Now let us subtract another term which is px x px square px n minus 1. So let us write it clearly, then we can understand what is its meaning. We will write it in the next step. Minus px n x. So that means if we x px minus px x px to the power n minus 1 plus this means px x px into px n minus 2. So let us subtract another term which is px x px n minus 2. So we subtract this term, so we have to add px square x px n minus 2 again. Then that means we have to again add some other term, subtract this term. Now we will subtract px square px x into px n minus 3. So if we do these times this, then we will get a term plus px n minus 1 x px. So we have to subtract a term, that will be px n minus 1 px x. Then we have to add another term, that will be px n x minus this term, that will be px n x. So this term will be cancelled. Now we know that this is IH cut. So IH cut px n minus 1, it will be plus px x comma px n minus 2. These two terms will be px square x px n minus 3. This will add to the last term, that will be px n minus 1 x px. So that means we'll get 1 2. So we'll get n such terms. So that means when the power n minus 1 means first power is 0, then 1 first, this is first term, this is 2 second term. Second term is corresponding to the power of px 1. That means this will be the nth term. Since the power is n minus 1, the term will be n. That means nth term is there. That means I h cut px n minus 1. That will be also I h cut px n minus 1. This also again I h cut px square into px n to the power minus 3. That will be px n minus 1 plus dot dot dot. In this manner we have to add n such term px n minus 1. So we'll get I h cut n px n minus 1. So if we put here in this here, so we'll get the value n equal to 0 to infinity I a by h cut to the power n 1 by n factorial n, there will be I h cut px to the power n minus 1. So that means it is nothing, this is nothing but, if we differentiate this with respect to del px, what we'll get, let's see that I px a by h cut, if we differentiate it, what we'll get, summation of n equal to 0 to infinity I a by h cut to the power n by n factorial px n minus 1. Since this sum will be from 1 to infinity, since at the zeroth order term it will be a constant, it doesn't depend on the px. That means first term will be 1 and that 1 into that term will be 1, so derivative with respect to px will be 0, so summation will start from n equal to 1 to infinity. That is the derivative of px to this term. Now let us see here what we'll get. We'll get exactly same thing I h cut, and here also at n equal to 0 this whole term will become 0. From here also we can see that at n equal to 0 this whole term is actually 0, because n at the upper part n is multiplied I h cut, that means n equal to 1 to infinity I a by h cut to the power n 1 by n factorial n px n minus 1, which is nothing but I h cut del px exponential I px a by h cut. So we get it the quantum mechanical commutation, that means x comma e to the power I px a by h cut is equal to nothing but the classical px a by h cut, the classical commutation, classical pi into I h cut. So we know that quantum, from here we can say that this quantum mechanical commutation relation will be nothing but the I h cut into the classical commutation. So that means we solve the question B of the problem. Now let us solve the question C again. Now let us see that what is the value here. Then the value will be I h cut into exponential, here this will be coming out from here I a by h cut exponential I px a by h cut, that means minus a e to the power I px a by h cut. That means x e to the power I px a by h cut minus e to the power I px a by h cut, x is equal to minus a e to the power I px a by h cut. So which means x e to the power I px a by h cut by h cut is actually e to the power I px a by h cut multiplied by x minus a e to the power I px a by h cut. Now in question C it is asked that prove that the exponential ipx by a by h cut x cap is a eigenstate of the coordinated operator x. So let us check that. So here it is asked that e to the power I px a by h cut x cap is also a eigenstate of the x operator. Let us see that. So that means x e to the power I px a by h cut x cap will be, that means from this relation we know that this is equal to nothing but e to the power I px a by h cut x minus a e to the power I px a h cut x prime. We know that x operating on x prime will give x prime. So that means it will give e to the power I px a by h cut x prime minus a e to the power I px a by h cut x kit. So that means x prime minus a, these two are the numbers, so we can interchange these two, x star minus interchange these two, so x star minus a, x dash minus a e to the power I px a by h cut x. So that means if we operate on this position operator on this state, we will get this state back, and this is the eigen, that means these are the eigengates of the x operator with eigen value x dash minus a. That means it nothing but, that means what it does, it shift or translate the state by amount minus a, or translate the state, translate the position of the state by an amount minus a. So this is basically a translation operator. So that is it.